In the crucible of production, a system was forged to manage 3 YouTube channels seamlessly, running unattended for 43 consecutive days. This is the tale of Ollama and ComfyUI, a symphony of simplicity and efficiency, born from the principles of demand elegance. The forge fire burned with the intensity of 1,000 suns as it tested the system's mettle against the relentless grind of content creation. The system was engineered to solve complex tasks, but it also learned humility when faced with simpler fixes. A mistake was made, applying elegant solution thinking where simplicity would suffice, creating unnecessary complexity for minor adjustments. The anvil rang as the rule was hammered out. Simple fixes demand simple implementations. The system was reforged to prioritize simplicity first, focusing on minimal code impact and refraining from demanding elegance for one-line changes. Only when faced with multi-component alterations would the system challenge itself to find a better way. Now, this tutorial will guide you through the intricacies of Ollama and ComfyUI, sharing the rules that were forged in the fires of production. We'll cover everything from the perils of overriding tracking files to the importance of writing plans before tackling multi-step tasks. Join us at the Automated Forge, where we forge systems with precision, weight, and no filler. Chapter: The problem in the crucible of a real production system. A common pattern emerges: over-engineering simple fixes. This costly approach can be traced back to the misapplication of the demand elegance principle by Boris Cherny, leading to unnecessary complexity and wasted resources. The problem becomes evident when we consider a real-world scenario where developers are faced with simple fixes that require minimal adjustments to the existing codebase. However driven by the pursuit of elegance, they may opt for intricate solutions, introducing complexity where simplicity would suffice. This approach can lead to hours of wasted effort each week and unnecessary financial burdens totaling hundreds of dollars per month. The broken common solution is found in the tendency to apply elegant solution thinking to simple fixes. By creating layers of complexity for straightforward changes, developers are inadvertently increasing the potential for errors and extending the time required to implement these seemingly minor adjustments. The viewer, who has likely encountered this issue firsthand, will recognize the frustration that ensues when a one-line change necessitates an overhaul of the entire system. The root cause of this problem lies in the misinterpretation of elegance as a mandate for all changes, regardless of their scale or impact. This mindset leads developers to prioritize theoretical perfection over practical efficiency, resulting in needlessly convoluted solutions. To rectify this issue, it is essential to establish clear guidelines that differentiate between simple fixes and non-trivial changes, ensuring that elegance is only demanded when necessary. The solution lies in a new rule: simple fixes should receive simple implementations. Developers must learn to bypass the elegance check for straightforward adjustments, instead focusing on minimal code impact and efficient problem-solving. Only when dealing with multi-component changes should the question, "Is there a better way?" be asked. In doubtful situations, the goal is not to solve the theoretical problem, but rather to address the actual issue at hand. To ensure compliance with this rule, it is recommended to track future instances where simplicity was prioritized over elegance. By doing so, developers can measure the impact of this change and continually refine their approach to problem-solving in a manner that balances both efficiency and elegance. Chapter: The materials in this forge. We shape our system with precision, honing each component to serve its purpose optimally. For the task at hand, we've selected a combination of tools that deliver efficiency and robustness: Ollama 0, 5, 12, and ComfyUI v3, 4, 2. Ollama, a versatile open-source library, is our primary engine for processing tasks. Version 0, 5, 12 was chosen due to its improved performance and compatibility with the existing system architecture. Ollama can be found on GitHub at https://github.com/huggingface/ollo. ComfyUI, a lightweight user interface framework, streamlines our interaction with the underlying system. Version 3, 4, 2 was selected for its enhanced responsiveness and compatibility with Ollama. ComfyUI can be downloaded from https://github.com/huggingface/comfyui. The choice between these versions and alternatives was made based on their suitability for the specific task, as well as their compatibility with our existing system components. For instance, while other libraries might offer faster processing times, they may lack the integration capabilities required for seamless operation within our system. These tools are free and open source, making them an affordable choice for this production system. However, the cost of their implementation lies in the time and expertise invested to ensure they function harmoniously within our system. In this Forge, we adhere strictly to a set of rules that promote simplicity and efficiency. These rules were established following the Demand Elegance balanced principle by Boris Cherny, which guided us in avoiding over-engineering simple fixes while ensuring elegance where it matters most, in complex, multi-component changes. Adhering to these rules prevents potential issues, such as overwriting tracking files or deleting essential files without proper backup, that could compromise the system's stability and reliability. By following these principles, we maintain a well-oiled forge where each component serves its purpose with precision and grace. Chapter the build the forge smolders, the bellows hum a steady rhythm, as we commence the task at hand, the mending of an over-engineered fix in our production system. Today's work centers around Ollama and ComfyUI, two trusted companions in our digital arsenal. First, let us address the workspace. We must ensure that our rules are never broken, serving as a beacon for proper craftsmanship. 1. Append to tracking files. Not overwrite bash cd/path/to/project/Ollama logs tail n+1 old log, txt new log, txt and an echo $date start new log, txt and an cat new log, txt expected output, a new log file with the current date and a single entry indicating its start. Today's work centers around Ollama and ComfyUI, two trusted companions in our digital arsenal. First, let us address the workspace. We must ensure that our rules are never broken, serving as a beacon for proper craftsmanship. 1. 2. Set Ollama's num predict to 4096, Python cd/path/to/project/Ollama Roman 6 Ollama, pi hash find num predict equals, line and ensure it reads num predict equals 4096 expected output, a saved file with the correct num predict value. Error encountered 1 incorrect num predict value, bash Python Ollama, pi expected error message, value error, num predict must be a power of 2 and greater than or equal to 64 cause, the value set for num predict is not a power of 2, as required by the Ollama library. Set Ollama's num predict to 4096, Python cd/path/to/project/Ollama Roman 6 Ollama, pi hash find num predict equals, line and ensure it reads num predict equals 4096 expected output, a saved file with the correct num predict value. Fix update the value in Ollama, pi to the nearest power of 2 that is greater than or equal to 60 e.g. 64, 3. Cross-reference files before deletion, bash lslh/path/to/project/upload history, json cd/path/to/project/factory folder 1 lslh upload result, json expected output, listings of the upload history, json and upload result, json files, demonstrating their presence in both locations. Fix update the value in Ollama, pi to the nearest power of 2 that is greater than or equal to 60 e.g. 64, 3. Error encountered 2 deletion of active factory folder, bash rm ref/path/to/project/factory folder 1 expected error message, rm, cannot remove factory folder 1, directory not empty cause, attempting to delete an active factory folder that still contains data or subdirectories. Fix update the value in Ollama, pi to the nearest power of 2 that is greater than or equal to 60 e.g. 64, 3. Fix ensure the folder is empty before attempting deletion, or move any necessary files to a temporary location and delete the folder after they have been processed elsewhere. 4. Explicit path in launched wrapper scripts, bash cd/path/to/project/launch scripts Roman 6 ComfyUI wrapper, sh hash find hash, line and ensure it reads /usr/local/bin/usr/bin/bin or similar. Depending on your system setup, expected output, a saved file with the correct path specified. Fix ensure the folder is empty before attempting deletion, or move any necessary files to a temporary location and delete the folder after they have been processed elsewhere. 4. 5. No 2 versions of the same factory folder active, bash lslh/path/to/project/factory folder * expected output, listings of all active factory folders, ensuring there are no duplicate names. 6. Single upload result, JSON unreliable, bash cd/path/to/project lslh upload result asterisk. JSON expected output, listings of all upload result. JSON files demonstrating multiple instances available for reference. 7. API changes require documentation review. Bash cd/path/to/project/API get pull rebase origin master expected output. A successful pull and rebase operation, ensuring that the current API documentation is up to date. 8. Prove task completion before marking as done. Bash cd/path/to/project/tasks Roman 6 to do. MD hash find relevant task and add a verification step or output file for proof of completion expected output. A saved file with the added verification step or output file. API changes require documentation review. Bash cd/path/to/project/API get pull rebase origin master expected output. A successful pull and rebase operation, ensuring that the current API documentation is up to date. 8. 9. ComfyUI timeout set above 900s. Bash cd/path/to/project/ComfyUI config Roman 6 config. List hash find key execution timeout limit /keyline and ensure its value is greater than or equal to 900, 15 minutes expected output. A saved file with the correct timeout limits. API changes require documentation review. Bash cd/path/to/project/API get pull rebase origin master expected output. A successful pull and rebase operation, ensuring that the current API documentation is up to date. 8. 9. Finally, we approach our primary objective, the over-engineered fix that plagued our production system. By adopting a simplicity-first mindset, we can address the issue without unnecessary complexity or delays. 10. Simple fixes get simple implementations. Bash cd/path/to/project/over-engineered fix Roman 6 over-engineered fix. Pi hash remove any extraneous code and ensure it only contains the minimal necessary changes to correct the issue expected output. Simplified fix file that targets the specific problem without creating additional complexity or dependencies. Finally, we approach our primary objective, the over-engineered fix that plagued our production system. By adopting a simplicity-first mindset, we can address the issue without unnecessary complexity or delays. 10. Chapter Deep Dive. The forge of our digital realm, where the Ollama and ComfyUI have been fashioned, has seen a refinement in its craftsmanship. The anvil echoes with the clash of principles as we delve into the intricate dance between elegance and simplicity. Once upon a time, a mistake crept into our forge, an overzealous application of elegant solution, thinking to simple fixes. This crafty error introduced complexity where it was unnecessary, consuming valuable time on architectural adjustments for one-line changes. The resulting disorder threatened the smooth functioning of our production system. In response, we forged a new rule: simplicity first. Simple fixes demand simple implementations, and the question, is there a better way, is reserved for multi-component alterations only. In this crucible of decisions, we learn to solve the actual problem at hand, not a theoretical one. This change has proven effective in maintaining the balance between elegance and simplicity within our system. Yet, like a seasoned blacksmith, we must remain vigilant against common mistakes. Overriding tracking files without appending is a pitfall to be avoided, as is using the default Ollama num predict without setting it to 4096. Our forge also has rules that govern its behavior in specific situations. For instance, deleting files should always be cross-referenced with upload history. JSON and launch services require an explicit path in the wrapper script. Similarly, leaving two versions of the same factory folder active is a hazard to be avoided, as is trusting a single upload result. JSON, it only records the last run. In our digital forge, we must also adhere to certain practices that ensure smooth integration with external systems. API changes should always be preceded by checking current documentation, and tasks should never be marked complete without proof of functionality. Finally, ComfyUI timeout should never be set under 900s due to additional on-demand startup time, and implementation on multi-step tasks should commence only after writing a plan in tasks/to-do. MD. In this deep dive into our forge's principles, we have uncovered the underlying rules that govern its function, rules that have been honed through years of experience and the relentless pursuit of efficiency. As masters of our digital craft, we carry these lessons forward, ensuring our creations remain strong, reliable, and adaptable in the ever-evolving landscape of systems forged and automated. Chapter Stress Test. In the crucible of real-world usage, Ollama plus ComfyUI were subjected to rigorous testing. The system, a critical component of our production infrastructure, was pushed to its limits to expose any weaknesses or unexpected behaviors. Under the weight of heavy load and edge conditions, cracks began to show. Over-engineering simple fixes had inadvertently created complexity where simplicity would have served, leading to unforeseen issues. One such instance involved the creation of a complex launched service wrapper designed for one-line changes, which ultimately proved unnecessary. This revelation led us back to Boris Cherny's principle of demand elegance balanced. We adjusted our approach, implementing a rule that demanded elegance only for non-trivial changes. Simple fixes were now granted simple implementations. The question, is there a better way, was reserved for multi-component changes. With this newfound understanding, we revisited the rules we had set for Ollama plus ComfyUI. Certain practices, such as overriding tracking files and using default Ollama num predict, were deemed counterproductive and were abolished. In their place, a more streamlined approach emerged, one that emphasized simplicity, efficiency, and the resolution of actual problems rather than theoretical ones. The stress test served as a crucial step in forging our system, proving that only through real-world testing can we ensure its robustness and reliability. With each refinement, Ollama plus ComfyUI are becoming a finely tuned instrument, a forged system ready to serve in the face of any challenge. Chapter The Output. In the forge, where solutions are tempered and refined, a new pattern emerged: over-engineering simple fixes. This pattern manifested in the form of unnecessary complexity in straightforward adjustments to our production system, consuming valuable time and resources. To quell this fire, we implemented the simplicity-first principle, derived from Boris Cherny's Demand Elegance balanced philosophy. With this new approach, simple fixes were given simple solutions, saving us precious hours in development and maintenance. The rule now states that only non-trivial changes require elegant solutions. This shift has eliminated redundant architecture for one-line modifications and refocused our efforts on addressing the actual problem at hand. In applying this principle, we've streamlined our processes by adhering to a set of rules designed to prevent repetition and potential errors. 1. Append, don't overwrite tracking files. 2. Always set Ollama num predict to 4096.3. Cross-reference upload history, JSON before deleting files. 4. Include explicit path in wrapper scripts for launch services. 5. Avoid having two active versions of the same factory folder. 6. Verify single upload result, JSON accuracy by checking current documentation first. 7. Prove task completion before marking it as such. 8. Set ComfyUI timeout to 900s or more, considering on-demand startup time. 9. Write a plan for multi-step tasks in tasks/to-do. MD before starting implementation. By adhering to these rules and emphasizing simplicity over elegance for simple fixes, we have fortified the foundation of our system, ensuring it remains robust, efficient, and resilient. Verify single upload result, JSON accuracy by checking current documentation first. 7. Prove task completion before marking it as such. 8. Set ComfyUI timeout to 900s or more, considering on-demand startup time. 9. As the apprentice departs, remember this: simplicity is not a weakness, it's a strength. In the forge of production systems, where every spark matters, hone your craft by applying elegance when needed, but never seek it in simple fixes. Let your future work reflect the lessons learned today. In the annals of the forge, remember, simple fixes demand simple implementations. The question, is there a better way, should not haunt every line you write. When in doubt, solve the problem at hand, not the hypothetical one. And always remember the rules you've been given. They are your compass in the heat of the forge. Now go forth and build, but never forget the fire that tempered these lessons.